Okay, equations in that are in quadratic form but don't necessarily look quadratic. So by the fundamental rule of algebra, this this is a fourth degree polynomial, so we know we have four answers. And so, and it kind of looks like a trinomial with an x squared trinomial. So what we can do is let u equal x squared, and then substitute that back in this case. And what happens is you get this, so x to the fourth would be u squared minus 25u plus 36 equals 0. And so now we can solve this based on u, and then come as a quadratic. So like any quadratic, we'll go ahead and factor it first to see if it works, and I'm just going to throw in some numbers and hope it works. And maybe looks like 6 and 6, 9 and 4, 18, 18 and 2. My guess is 2 and 2 doesn't work. So we'll try a different route. We'll go 4u and 1u, and we'll try 9 and 4 and see if that works. And so that would be 16u and negative 9u, sorry, and it's negative 16u, which would be negative 25u. So that is correct. So using the zero product theorem, so 4u minus 9 could be 0, or u minus 4 is 0. And so you solve each of those. So u is either equal to 9/4 or u is equal to 4. Well, we know that u is equal to x squared, and we really ultimately want to know what the answers to x are. So instead of u now, we'd have x squared equals 9/4 or x squared equals 4. And so then you solve each of these equations. Well, the opposite of x squared is the square root. And so x would equal plus or minus 3/2. So there's two answers. And do the same over here. Square root both sides. X is equal to plus or minus 2. And so there are our four answers for this equation. Okay, so that's that one. What happens if it looks like this? Okay, also you can kind of see the quadratic forming here with the squared here and the first power here. So we just need to eliminate this x to the 1/3 idea. So we're going to let, in this case, let u be 1/3. Or sorry, x. Yeah. u be, sorry, that's wrong. Not 1/3. X to the 1/3. Sheesh. So we'll let u equal x to the 1/3, and then plug those in. So then 3, you'd have 3u squared, because the 1/3's gone, minus 5u minus 2 equals 0. And I'm assuming this factors. So 3u minus 2u plus 1, and maybe we got lucky. You check it, that'd be negative 2u, positive 3u, darn it, that gives us positive 1u. So we'll rearrange the 2 and the 1. I'm going to put the 2 here and the 1 here. That gives me negative 1u and positive 6u. That's 5u, so that just means my signs are wrong. So this needs to be positive, this needs to be negative, and so now, using the zero product rule, we know 3u plus 1 equals 0, or u minus 2 equals 0, and so u is equal to negative 1/3, or u is equal to 2. Again, we are trying to solve for x, so we substitute back in what we had u set equal to. So we know x to the 1/3 is equal to negative 1/3, or x to the 1/3 is equal to 2. And so now we need to solve these. Well, to eliminate a rational exponent, you do a power of both sides by the reciprocal of that exponent. And so 1/3. And the same with this one. Oh, not 1/3. 3 over 1 is the reciprocal. Jeez, been doing too many of these. So 3 over 1, 3 over 1, and 3 over 1. And so we know x to the first power, which is just x, is equal to negative 1/3 to the third power, which 1 to the third power is 1, negative to the third power is negative, and 3 to the third power is 27. So we know one of our answers is negative 1/27. This side over here, or x is equal to 2 to the third power, which is just 27. And so there are my two answers for this particular problem. All right, so hopefully this helps. If you have questions, make sure you ask. Good luck, and see you later.